Hey there, and welcome to DevSecTalks. I'm your host, Ashley Ward, and today I'm joined by Ory, the Senior Director of Product Management at Palo Alto Networks. If you've worked in the DevOps space, you've most likely come across the term API, or Application Programming Interface. But what's the actual significance of them? We'll discuss the basics of APIs and their use cases, as well as the actual security challenges that come with this critical component of modern software. Let's get into it.
My name is Ory Segal. I'm Senior Director of Product Management for Prisma Cloud. My team is responsible for the web app and API security module, which is a part of Prisma Cloud Compute. All in all, I've spent the past 20 odd years researching and developing industry-leading products for application security.
So I'm from an infrastructure background. I was an ops guy. I was a Unix admin back in the day. So I'm very well aware it's easy to throw around the phrase API. And of course, when I speak to people, they always go, yeah, well, as long as there's an API for that, then we're good. Of course, application programming interface, great. What does that mean though? What are we actually talking about? Give me some context around it.
It's actually pretty simple. In essence, if you take two modern day applications, could be web applications, mobile applications, they need a way to communicate. If in the past, 20 years ago, we talked about network-based communications with all sorts of protocols. Today, APIs are essentially the way for applications to interact with each other. Mostly APIs are consumed and served over HTTP, over the web. And that is the interface by which two or more applications will communicate these days.
Presumably then, everybody's publishing APIs. You've got an application, you've got something there that's talking to different applications. We've got APIs there to serve those purposes. I mean, what's they must be pretty static. They're just created. I mean, what's the how do we know who's consuming or there must be more to this. I mean, are they changing often? What's the deal?
Yes. So essentially with modern application development, especially cloud native, APIs change almost on a daily basis. So you have developers exposing new functionality of the application. Think about the API server as the backend where the logic runs, and then you have the client, the consumer. Could be mobile web application, could be an IoT device, could be B2B. Essentially, every time a developer changes the code or exposes new functionality, they issue or expose a new version of the API. There are different ways to locate these APIs or to know about the existence. I'm sure we're going to cover that in a moment, but essentially they are, for every application today, there are dozens, if not hundreds of APIs, and they are constantly changing. Whenever there's a new build, a new functionality, that can happen a few times a day, could happen once a week or more. The APIs change, their URL change, and the message format for them can change.
Okay, so you mentioned there actually an important point. So when I think about APIs, I'm thinking about web applications that are exposing APIs. But you mentioned, of course, the different backends. What are some of the things that would be providers? What's exposing APIs? Give us a rundown.
So the basic API I think started with libraries. So if you take a look at open source libraries that do all sorts of things, they expose an API to the developer. Essentially, the method or the function call that the developer uses to consume or to actually use that library. Obviously, there are web applications that expose web APIs. They are backend applications for mobile applications. So your mobile phone actually runs only the front end, and then data goes back and forth between the mobile applications and the backend API server. Other examples could be, IoT devices that communicate back to the cloud, could be sending telemetry data, for example. Those are the main consumers and servers of modern day APIs. And of course, if you break down your application into microservices, if you follow, microservice-oriented development, cloud-native applications, containers, then microservices will interact with each other in what's referred to as east-west API traffic between the microservices inside the cluster.
Okay, that's really good. So we're saying there that, of course, it's a bedrock for modern applications, that we've got this covering across a number of different backends and different providers that are there. We've got, you've mentioned that there's a lot of change. Is there any standardization there? I mean, if you're talking about going back 20 years of APIs, there must have been many different standards that have come along. Is there something in common use at the moment?
Before we get to what's happening today, I think if we take a short detour, historical detour. Originally, we had SOAP web services, if you remember those, and SOAP web services were described using WSDL files, or WSDL, web service description language. That really didn't catch. It was too cumbersome and didn't really got adopted. Today, with microservices and with APIs, what we're seeing is a much better adoption for a standard called OpenAPI. It used to be called Swagger. Swagger files. Essentially, it's a specification that describes the different endpoints. So, who do you turn to get whatever you want from the API, as well as the message format, the parameters, their data types, the values they expect. Essentially, everything in the OpenAPI allows you to create a client, an API client from scratch without having to know anything about the API itself.
From a security point of view, we're really just talking about making sure that only the right things talk to the providers. So only the right consumers are allowed to talk to the providers, right?
Not quite. So the OpenAPI specification, as I mentioned, describes the server side and what the server side expects to receive. So message format, what parameters, what the client should expect as a response. It does not talk about who can access the API. It does not mandate any kind of authorization and authentication whatsoever. That's left to other intermediary devices, for example.
But if everything's documented, if we've got an open API specification that's there that says, hey, this is all the stuff, then I mean that's a really good first step. I mean, is that something that gets automatically created from the APIs that are exposed, or is that something that needs to be handcrafted? What's the story with that?
So it could. Essentially, an open API specification document is, and I forgot to mention that earlier, is either specified in JSON, so JavaScript object notation, or YAML. Those are lightweight if you compare them to SOAP and WSDL files. And those documents can be created automatically when you update. And again, it depends on the infrastructure and the platform that you're using. If you're using some kind of off-the-shelf commercial API gateway, then those gateway servers have the ability to automatically generate an OpenAPI spec file for you. However, they will not automatically be updated, which is, I guess, one of the biggest problems with modern day APIs is the fact, the visibility, your way of controlling which APIs are exposed and which are not. Oftentimes, these documents will be outdated. Developers haven't generated an open API spec for the latest APIs out there. In that case, it could either break an application if a developer, an API client developer, relies on that sort of contract that's outdated. You're going to have a problem, a functional problem. It's going to break the API. On the security side, you cannot protect what you don't know actually exists. So if you try to enforce some kind of security using the API spec document and that document is outdated, you probably don't know what you need to protect, and you're probably going to use the wrong kind of security for those APIs.
Yeah, it's because it's more than just potentially breaking an application when it's getting a response that's different from what it expects because the OpenAPI document hasn't been updated. But actually, yeah, that's a good point. So there's then that security realm of, well, you could potentially end up with APIs that you don't even know are exposed, and that's.
Yeah, so
Okay.
governance is a big part of securing APIs, governance and visibility. If your open API spec is up to date, you could probably load it to a security intermediary device that will enforce some kind of security. If that document is not representative of the reality, then obviously that security device will not know about APIs. You won't know about APIs, and that leaves gaps in your security posture. Yes.
Yeah. Okay. That makes a lot of sense. So we're talking about it from a security point of view. Then, this obviously you've been in the industry for a while. You've seen all the different changes out there. Is this still a problem simply because of the amount of change that's going on with it from an API point of view, or do you think how's the industry looking at this?
So open APIs are, I think, almost yesterday's news. The world has changed. Any web app today, that you develop exposes APIs. Any mobile backend application exposes APIs. IoT device expose APIs. Every modern application relies today on API. That's the de facto way for applications to communicate today. If you look at a company that's developing a front end, a web interface for a new product, that web interface always talks through APIs to the backend, to the core logic. Nobody does anything different. That's really the de facto way for applications to communicate today. And securing APIs is a serious problem. Today, we're actually seeing attackers target APIs more than they target other forms of communication for applications. And there's a good reason for that. One of which is that it's hard to secure APIs. It's hard to govern them, to apply authorization and authentication. There are so many, each application exposes really dozens, if not hundreds of APIs, and being able to control access and detect attacks over APIs is hard. If you take a look at credential abuse attacks, I think I saw an article in 2019, 75% of all credential abusing attacks against the financial industry were over APIs. So attackers today will start with with attacking an API before they try the more sophisticated vectors of attack, because there are many APIs. They expose a lot of backend logic, a lot of sensitive backend logic. It's very easy to abuse them, and it's very hard to secure them. A lot of these attacks are carried using bots and automated scanning tools, and the common ways that we have to stop bots and automation scripts, usually with JavaScript and CAPTCHA and all sorts of anti-automation, that really doesn't fit the world of APIs, where it's machine to machine anyway. So it's hard to enforce human-only traffic. So attackers discovered that it's harder to detect attacks over APIs. There's less visibility usually to monitoring over APIs. It's, as I mentioned, it's harder to stop automated scripts, and so APIs would be their first choice of where to attack an application today.
I do like the idea of some sort of CAPTCHA. Are you sure you're a robot? This has to be a machine that was talking to this. And that's good. So, but is there anything out there then from a standards point of view? You mentioned open APIs, but is there anything from a security standard point of view that people can look at? I know we keep going on at the application layer about OWASP, but is there anything like that's applicable?
Yeah. So first of all, before we dive, into all sorts of lists like the OWASP top 10, we expect, or the expectation is that developers will keep the open API spec up to date. If there are intermediary security devices that can enforce, many API gateways allow you to enforce all sorts of things on APIs, like quota for API consumption based on API keys. But if you have an open API spec that's up to date, and if you can load it to, let's say, an API firewall, a web app firewall, usually those products will allow you to apply positive security. So remember that the open API spec contains the endpoints, the API endpoints, but also the message format. So if your API expects an integer, the spec file can actually define what's the numeric range of that integer, what are the data types that the API expects. And by that, you can apply positive security, again, depending on the platform that you're using to secure the APIs. And that positive security can go a long way to defend against at least the low-hanging fruit attacks. OWASP, and I'm pretty sure most of our viewers know about OWASP, the Open Web App security project. From every couple of years, they issue a list. There is an OWASP API top 10 security list that was issued, I believe, in 2019, and that covers the 10 most common risks for APIs. It's very similar with slight differences to the regular standard OWASP web app security. And the list contains, the standard things you would expect, like broken object level authorization, data exposure, broken function level authorization, mass assignment. These are categories. We don't have the time to go through each of the categories, but these are the top categories of risks that developers should bear in mind when developing and trying to secure APIs. And you can find that list very easily through Google and the OWASP website.
Now, we won't hold you to this. You don't need to put money on it or anything like that. Where do you think the industry is going? What developments do you see coming in the next couple of years around APIs?
Well, I definitely think that securing APIs, if we talk about security, we can go back to APIs in general, where I think that's going to go. But from a security standpoint, I do believe that as more and more applications expose more and more APIs, it's inevitable that customers will have, or API owners will have to get a grip on what they're exposing. They need to have visibility, a lot of visibility into the different APIs they're exposing, who they are exposing it to, the ability to do micro-segmentation and enforce who can access APIs, based on different client attributes. Obviously, DDoS against APIs, that's a big thing as well. The ability to apply a quota to API users, and of course, most importantly, to protect against those OWASP risks that we mentioned. So the ability to inspect API traffic, regardless of whether it's running on HTTP, HTTPS, HTTP2, APIs that use more modern protocols or message formats like GraphQL. That's definitely going to be big. In fact, we are seeing all the major cloud providers already providing GraphQL-based API platforms, and so GraphQL is going to be big. So in essence, you need to look for a modern API security solution that's on the protection side. From an API, I think I mentioned, so GraphQL is big, it's getting huge. Cloud-based APIs as well, and cloud events, which essentially work like APIs as well. So think about serverless functions. Those are triggered via events, essentially API calls, and they transfer a lot of data very similar to APIs. So really, APIs is becoming, as I said, the way for applications to communicate. It's so widespread that saying that that's the future is a bit funny, because, as I said, it's already here. But I do believe that as more and more applications become API or expose APIs, people are going to start changing the way they think about security and about networking, and starting to think about APIs. So it's no longer layer 3, layer 4 traffic with all sorts of native protocols. I think everything is going to talk web APIs, regardless of the language within the API. But that's, the world, that's sort of the new network, if I have to put it in one sentence. So APIs are definitely the way applications network and communicate with each other.
Thank you, Ory, for taking the time to chat with us today. And thank you for tuning in to this episode of DevSecTalks. Be sure to visit the link in the description below for details on the DevSecTalks series. And don't forget to subscribe and turn on channel notifications. We've got some amazing discussions in store for this first season of DevSecTalks. Make sure you're the first to know about all of our upcoming episodes. And if you're interested in being part of the DevSecTalks series, or if you have any potential speakers you'd like to recommend, feel free to let us know in the comments section below. Thanks again, and I'll talk to you soon.